Okay, section 10.4 is called Solving Quadratic Equations by Using the Quadratic Formula. This is yet another way to solve a quadratic equation when it's set equal to 0. So, summary of the methods that we've used so far. Graphing. Graphing, we've said, is only to approximate a solution in most cases. Sometimes it can be accurate, but a lot of the times you can't tell for sure where the graph crosses the x-axis. It might be in between two numbers, so we can't tell for sure. Factoring only works for some quadratic equations. If there are no factors, if the quadratic is prime, we cannot solve it using factoring. Complete the squares, the one we just did, it solves any quadratic. The leading coefficient must be 1, so sometimes you have to divide everything by 1. And it works best if b is an even number. So all of these have their shortcomings and their strengths. But the one we're doing today is called the quadratic formula. It can be used for any quadratic equation. The solutions of a quadratic equation in the form ax squared plus bx plus c equals 0, where a does not equal 0, that's our definition of a quadratic, are given by the solutions, are given by the formula, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So pause the video and write all this down. This must be memorized. You've got to know the quadratic formula. All right, let's see how it works. So in this particular quadratic, a equals 1, b equals negative 2, c equals negative 24. My formula, negative b plus or minus the square root of b squared minus 4ac over 2a. So opposite of b is negative 2, so the opposite of b is 2. Plus or minus the square root of negative 2 squared minus 4 times 1 times negative 24. I'm just substituting these values into the formula over 2 times 1. So x equals 2 plus or minus the square root. Negative 2 squared is 4. Negative 4 times negative 24 is positive 96. So I get x equals 2 plus or minus the square root of 100 over 2. Square root of 100 is a perfect square. And now I can find my two solutions. 2 plus 10 over 2, which is 6. And 2 minus 10 over 2, which is negative 4. So those are my two solutions found using the quadratic formula. Now, this particular quadratic could also have been solved using factoring. It would have been quicker, but since we're practicing the quadratic formula, that's what we used. Factors of negative 24 that add up to negative 2 are 4 and negative 6. X plus 4, x minus 6 equals 0. And then when I solve these, when I set them equal to 0, I have to move the number over so the sign will change. So you notice that my factors are 4 and negative 6, but my solutions are negative 4 and positive 6. Same solutions I got from the quadratic formula. Okay, let's try another one. So here we have another quadratic. Always, no matter what form you're using, you must first put it into ax squared plus bx plus c equals 0. Now, I notice that everything here is divisible by 2. So if I divide both sides by 2, since there's a 0 over here, I can get myself a little bit simpler values to work with. All right, using my formula, negative b, that becomes, let's do this again. I'm going to use a equals 12, b equals negative 7, c equals negative 3. So negative b plus or minus the square root of b squared minus 4ac over 2a. That's how I find my x values when y equals 0. It's how I find my x-intercepts or my roots. Opposite of b is 7 plus or minus the square root of negative 7 squared minus 4 times 12 times negative 3 over 2 times 12. 7 plus or minus the square root of 49, and then I get minus 48 times 3. I didn't do that on my paper. Minus, plus 144, because negative times a negative, all over 24. So that's 7 plus or minus the square root of 193 over 24. I can't simplify the square root of 193. So using a calculator, 7 plus the square root of 193 divided by 24, that gives me 0.8705, and 7 minus the square root of 193, all divided by 24, gives me negative 0.287. So you can see that this is a case where factoring would not have worked, where graphing would not have worked because it's in between two numbers, and where complete the square, if I had done complete the square, I would have first had to have divided by 12, because the leading coefficient has to be 1 for complete the square. And I would have had to use this b value for complete the square. That would have been really messy. So in this case, this is one of those where the quadratic formula is the best and simplest. Now, without a calculator, you are perfectly fine leaving your answer in this form. If you have a calculator, you can go ahead and get decimal answers, but without a calculator, this would be the best form to leave your answer in. Okay, there's one other thing that we're going to look at with our quadratic formulas, and that's something called the discriminant. The discriminant is the portion of the quadratic formula found under the radical side. In other words, b squared minus 4ac. And that group of numbers can give us some information about the quadratic. If b squared minus 4ac is greater than 0, there are two real solutions and therefore two x-intercepts. Because remember, my entire formula looks like this. So if this is a positive square root, I'm going to have a number plus that number and a number minus that number. That gives me two answers. If b squared minus 4ac is less than 0, there are no real solutions and no x-intercepts. So again, two x-intercepts would be something that looked like this. No x-intercepts would not cross the x-axis. If the discriminant is negative, I cannot take the square root of a negative number, so I don't get any solutions for this second scenario. The last is that b squared minus 4ac equals 0. If it does, we get one real solution, we get one x-intercept, and the x-intercept is also the vertex. So this is the case that looks like this, where it touches just one time. Let's look at this a little closer. If my discriminant is 0, all of that becomes 0, and I end up with negative b over 2a. Does that look familiar? That's where the vertex is. So if the discriminant, if the numbers under the radical are 0, the formula for the x-intercept becomes the same as the formula for vertex. So the x-intercept and the vertex are the same exact point. All right. Find the discriminant and determine the number of real roots. So remember, the discriminant is just b squared minus 4ac. So for this one, that's 10 squared minus 4 times 2 times 11. That's 100 minus 88. That's positive. Therefore, there are 2 real roots, and we can also say 2 x-intercepts. Let's try this one. Again, b squared minus 4ac. Negative 20 squared minus 4 times 25. That's 400 minus 400. That's 0. So there is 1 real root, 1 x-intercept, which also happens to be the vertex. All right, let's look at our last scenario. Don't forget that when it's not written in standard form, you have to add the 2 to the left-hand side. B squared minus 4 times A times C gives me 16 minus 24. That's negative. So there are no real roots, no x-intercepts. So that's how the discriminant works. It doesn't give us the actual solution, but it does tell us how many solutions we might have. All right, I want to take this quadratic and solve it all of the ways that we have learned so far. So the first way is to factor. So the factors of 15 that add up to 8, x plus 3, x plus 5, set each factor equal to 0. We did this back in the last chapter. So x is negative 3 and negative 5. Those are my 2 solutions. Second method is to graph. So to graph, I'm going to find negative b over 2 times a. I'm going to set up my table of values. Negative 4 in the middle. When I plug in negative 4, I get negative 1. When I plug in negative 5, I get 0. When I plug in negative 6, I get 3. I get the same values on the other side of my table. So 1, 2, 3, 4, 5, 6. Negative 6, 3. Negative 5, 0. Negative 4, negative 1. Negative 3, 0. Negative 2, 3. There is my graph, and you can see that my x-intercepts are still negative 5 and negative 3, the same values I got from factoring. Okay? Complete the square. So for complete the square, x squared plus 8x plus something. The number that goes in here is half of the middle squared. I add it to both sides. I now factor this. Take the square root of both sides. Don't forget your plus and minus. X plus 4 equals plus or minus the square root of 1. X equals negative 4 plus or minus 1. Negative 4 plus 1 is negative 3. Negative 4 minus 1 is negative 5. I still get the same solutions. And our last method is the quadratic formula. So negative b plus or minus the square root of b squared minus 4ac over 2a will give me my x values. So negative 8 plus or minus the square root of 8 squared minus 4 times 1 times 15 over 2 times 1. So I get negative 8 plus or minus the square root of 64 minus 60 over 2. X equals negative 8 plus or minus the square root of 4 over 2. Negative 8 plus or minus 2 over 2. So negative 8 plus 2 over 2 is negative 6 over 2, which is negative 3. Negative 8 minus 2 over 2 is negative 10 over 2, which is negative 5. So those are all the methods we've learned so far. And as we talk more about this, you'll see that there are some quadratics that work easier with different